Hello friends, welcome to Everything Yagnik. My name is Yagnik and in this video we are going to talk about first order differential equations, their properties and solutions. So without wasting any more time, let's get started. First order differential equations. In previous video, it was part 1. In that video, we had talked about first order differential equations, their definition and their types. Now this is the part 2. In this video, we are going to talk about solutions and properties of first order differential equations. So let's start with solutions of first order differential equations. Two methods are considered to solve the linear differential equation of first order. First, using the integrating factor. That means we can solve the first order differential equation using integrating factor. And the other method is method of variation of constant. Now let's first talk about integrating factor. If a linear differential equation is written in the standard form, y dash plus a of x into y is equals to 0, then the integrating factor is defined by the formula u of x is equals to e to the power integration of a of x into dx. Multiplying the integrating factor ux on the left side of the equation, that converts the left side into the derivative of the product yx into ux. Now the general solution of the differential equation is expressed as follows. Y of x is equals to integration of ux into fx into dx plus c upon ux, where c is an arbitrary constant. Now let's talk about method of variation of a constant. This method is similar to the integrating factor method. Finding the general solution of the homogeneous equation is the first necessary step. Y dash plus a of x into y is equals to 0. The general solution of the homogeneous equation always contains a constant of integration, c. We can replace the constant c with a certain unknown function c of x. When substituting this solution into the non-homogeneous differential equation, we can be able to determine the function c of x. This approach of the algorithm is called the method of variation of a constant. However, both methods lead to the same solution. Now let's talk about properties of first order differential equations. The linear first order differential equation possesses the following properties. First property is it does not have any transcendental functions like trigonometric functions and logarithmic functions. And the other property is the products of y and any of its derivatives are not present in first order differential equations. Now, if you are looking for the transcendental functions, then here is the definition. A function not expressible as a finite combination of the algebraic operations of addition, subtraction, multiplication, division, raising to a power and extracting a root. It's called transcendental functions. Here are the few examples of transcendental functions. Log x, sin x, cos x, and exponential functions, and any functions containing these functions. Now let's talk about problems and solutions. So here is the first question. Solve the equation y dash minus y minus x into e to the power x is equals to 0. Let's start the solution. First of all, we have the equation y dash minus y minus x into e to the power x is equals to 0. Rewriting the equation, we get y dash minus y is equals to x into e to the power x. Name that equation as equation 1. Then f of x is equals to x into e to the power x. Name that equation 2. Because we are comparing that equation 1 with the standard equation. And the auxiliary equation is y dash minus y is equals to 0. That is going to help us. Comparing the equation with y dash plus a of x into y is equals to 0, we get a of x is equals to negative 1. Using a of x is equals to negative 1 in the integrating factor, u of x is equals to e to the power integration of a of x into dx is equals to, putting the value of a of x is equals to negative 1, we get e to the power integration of negative 1 into dx. This leads to e to the power negative of integration dx. And we know that the integration of dx is x. Hence, we have u of x is equals to e to the power negative x. Therefore, the integrating factor becomes u of x is equals to e to the power negative x. Name that equation, equation 3. Now the general solution of the linear equation is y of x is equals to integration u of x into f of x into dx plus c upon u of x. From 2 and 3 it becomes y of x is equals to integration e to the power negative x into e to the power x dx plus c upon e to the power negative x. We have just put the value of u of x and f of x. Then y of x becomes integration x dx plus c upon e to the power negative x. Therefore, y of x is equals to e to the power x in bracket x square by 2 plus c, which is the required solution. So we have got the solution of first equation. Now let's talk about another question. Solve the equation y dash plus 2xy is equals to x. Let's start the solution. The given equation y dash plus 2xy is equals to x is already in the standard form. Comparing it with y dash plus p of x into y is equals to qx, we get p of x is equals to 2x, name that equation 1, and q of x is equals to x, name that equation 2. Now u of x is equals to e to the power integration of p of x into dx. Now putting the value of p of x in this formula, we get e to the power integration 2x into dx is equals to e to the power x square, because we know that the integration of x dx is x square by 2, and cancelling the 2 from denominator and numerator we get x square. So u of x becomes e to the power x square. Now the general solution of differential equation is y of x is equals to integration u of x into q of x into dx plus c upon u of x, where c is an arbitrary constant. From 2 and 3, y of x is equals to integration e to the power x square into x into dx plus c upon e to the power x square is equals to 1 by 2 e to the power x square plus c upon e to the power x square. We have just put the value of u of x and q of x in this equation, and just simplifying that, y of x becomes 1 by 2 plus c into e to the power negative x square, which is the required solution. So we have obtained the solution of the given equation. That's it for this video. If you like this video, then don't forget to subscribe to Everything Yagnik for more upcoming mathematics videos like this. Share this video with your friends and family. Thank you.